All right, so what is math without a word problem? Yeah. So everybody's like, when do I use this in real life? Well, here you go. Word problem. So here we're talking about the fire department. And we'll talk about fire department and law of sines, law of cosines later on too. But here it says the fire department's longest ladder is 110 feet long. And the safety regulation states that they can use it for rescues up to 100 feet off the ground. So the ladder is 110 feet, but they can only go up to 100 feet when it comes off the ground part. So the highest part. So in other words, the angle of it. Yeah, we'll talk about that. What is the maximum safe angle of elevation for the rescue ladder? Which we just talked about, angle of elevation and angle of depression. So round your answer to the nearest whole number. Okay, so we're talking about let's say we have a fire truck right here. Fire truck. Woo, 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 woo. Fire truck. Woo. All right. And says that the ladder is 110 feet. And when it comes to rescues, when they rescue people with ladders, that means they're going to a building or they're looking at a building and they're trying to get up to a high level. So let's say we have a building right here. Nice building, nice building. They say that the ladder is 110 feet, but in other words, the building that they have to have has to be no more than 100 feet. So here we're going to say this building is 100 feet off the ground. And a ladder here is 110 feet. So the longest ladder is 110 feet. So from the fire truck to the building, it's 110 feet. And it says that the safety regulation states that they can use it to for rescues up to 100 feet. So they can rescue this the highest can go when it comes to the height. So with this part here, we're talking about what is our, sorry, let's do this. So I'm going to move this fire truck because I didn't do it right. Sorry, I didn't draw that right. All right, so here, there we go. Sorry about that. So this is our fire truck. This is what it should be. So it talks about our angle of elevation. What is the maximum safe angle of elevation? Remember, angle of elevation means from the ground up or from the horizontal and up. So here, we're going up for this part. So they want us to find this angle right here. And again, the ladder is 110 feet. When it comes to the actual rescue, it can only go up to 100 feet for the building itself. The building can only be 100 feet, a max 100 feet. So we're trying to find this angle right here with these parts. So if we look at it, we know, if we label it from here, we know this side is opposite, so that's our opposite side. It's across from it. We know this is our longest side, so this is our hypotenuse. We know this bottom part down here is adjacent side because it's next to the angle. Okay, so that means we're going to have to look at opposite and hypotenuse. So we have to figure out what trig function deals with the opposite side, which is 100, and hypotenuse, which is 110. Which hopefully everybody says sine. Yes, that's opposite of our hypotenuse. And so we need to find the angle. So just like we talked about before, I believe it was example 3 or 4. I think it's 3. Example 3. When we talk about finding our angle, means we have to do our inverse. So in this problem, we're going to have to find the inverse because we need to find the angle. So it means inverse. Use inverse. Use inverse. All right, so here we're going to fill everything in first. So we don't know what theta is, so we keep it as theta. And that's 100 on top, 110 on the bottom. And it goes back to exactly what we did in example 3. So we're going to do our sine inverse to get rid of the sine part and just have the angle. That's 100 over 110. All right, and we're going to put that into the calculator, and we know already this left side cancels out because our sine and sine inverse are opposites of each other, so they're gone. So we're left with just theta. And so we're dealing with sine inverse 100 over 110. Oop, don't move it, don't move it. Okay, and then when you put that in the calculator, you'll get an angle of about 65 degrees. And then that's it. That's all we got to do for this problem. So it says round to nearest whole number. So it's approximate, but the problem says round to nearest whole number. Nearest whole number. So it means here we're going to do the approximate sign. Sorry about that. So they approximately 65 degrees. All right, and then that's it. So the only thing is you're going to have to make sure you know how to set up the triangle correctly from the word problem. And we'll do more word problems and stuff, so you're not like, Mr. Hall, like you just did one and that's it. But that's it. That's cool. So here, that's in the notes for this.